Welcome to the Turf Zone podcast. This episode features the article Biochar Revisited, Rethinking Its Promise for Turf and Landscape Soils, written by Anthony Will and read from New England Blade magazine. In recent years, interest in biochar has grown rapidly, but so has the confusion about what it actually is and how it works as a soil amendment. Turf managers searching for guidance may find thousands of articles and research papers, many of which make conflicting claims about soil health, nutrient retention, and carbon storage. What's really going on? Let's start at the beginning with some key term definitions. Biochar, what is it? Biochar is produced by heating biomass to a high temperature in an environment with little or no oxygen. This heating process is known as pyrolysis. To understand this fully, it is helpful to define biomass and pyrolysis. Biomass is organic material derived from living or recently living organisms, primarily plants. Common examples include wood chips, walnut shells, crop residues, and manure. There are literally hundreds of different biomass materials that can be converted into biochar. Pyrolysis refers to the process and the equipment used to convert biomass into biochar. When biomass is heated under low oxygen conditions, most of the volatile components are driven off as gases and vapors, leaving behind a charcoal-like material that is rich in stable mineralized carbon. Modern commercial pyrolysis systems are far more effective at producing high-carbon, low-ash biochar than earlier or less controlled methods. Not all biochar is the same. It comes in many forms depending on the feedstock and how it's produced, so not all biochar behaves the same. High-quality biochar offers a remarkable range of benefits for soil health and plant performance, while a lower-quality biochar may contain excessive ash, low carbon content, or inconsistent physical properties. Until recently, there were no commercial-scale pyrolysis plants in New England producing consistently high-quality biochar. Charging biochar, what's the purpose? Raw biochar acts like a sponge. It readily absorbs moisture and nutrients from surrounding materials, which is why it is commonly used in filtration and remediation applications. Before being blended into soil, biochar should be charged, also called inoculated, with moisture, nutrients, and beneficial microorganisms. This is most commonly done by mixing biochar with high-quality leaf compost and allowing the blend to age or stockpile for a month or more. This step prevents the biochar from temporarily tying up nutrients after application. High-quality biochar, practical value for turf managers. When properly produced and inoculated, high-quality biochar offers a wide range of benefits to soil health and plant performance. Efficiency. A little goes a long way. Using a high-quality biochar, even at just 5% by volume, can make a real difference in soils. When incorporated into root zones or planting beds, about 2 5-gallon pails per cubic yard, premium inoculated biochar has been shown to boost water retention, nutrient availability, and soil microbial activity. Depending on soil conditions and goals, blend rates of 5–10% of a high-quality biochar can deliver lasting improvements in soil health and plant performance. Soil physical benefits. Improved soil structure. Biochar improves aeration, drainage, and aggregation. Its porous structure creates space for air and water movement, supporting deeper and healthier root systems. Reduced soil compaction. Incorporation of biochar can reduce bulk density and improve root penetration in compacted soils. Water retention. Biochar improves soil's ability to retain moisture, reducing irrigation demand and helping plants tolerate drought stress. Soil nutrient and microbial benefits. Nutrient retention. Biochar has a high capacity to retain nutrients, reducing leaching and improving nutrient availability over time. Microbial habitat. The pore structure of biochar provides habitat for beneficial soil microorganisms, increasing microbial diversity and enhancing nutrient cycling. Heavy metal sorption. Biochar can absorb certain heavy metals, reducing their bioavailability. This is particularly beneficial in disturbed or urban soils. Plant and environmental benefits. Carbon sequestration. Since biochar is extremely stable, it sequesters carbon for decades or even centuries, helping reduce atmospheric carbon dioxide. Enhance plant performance. Collectively, these benefits support improved plant vigor, resilience, and overall performance. Odor reduction. Biochar can help reduce undesirable soil odors, improving working conditions in landscape and urban environments. Long-term stability. Unlike compost, which decomposes over time, high-quality biochar remains stable in the soil for decades, continuing to deliver benefits long after application. Evaluating biochar. What turf managers should know. The only reliable way to evaluate biochar quality is by reviewing laboratory test results. Manufacturers should be able to provide basic analytical data for any product containing biochar. Turf managers should at least check a biochar's organic carbon and total ash content, aiming for higher carbon levels and lower ash to get the best benefits for soil health and long-term carbon storage. As a general guideline, high-quality biochar typically has a high organic carbon content, often above 50–60% according to IBI and EBC standards, and relatively low ash content, 5%. With lower percentages considered preferable for soil and carbon sequestration applications. Additional test parameters, such as pH, surface area, and stability, can provide valuable information, but carbon and ash content are the essential starting points before using biochar as a soil amendment. Biochar resources. What's available to turf managers? In the spring of 2024, Standard Biocarbon brought their modern biochar production facility online, the first commercial-scale plant of its kind in New England. Located next to a lumber mill in Enfield, Maine, the operation converts responsibly sourced wood chips into a stable form of organic carbon through the pyrolysis process. With consistent, high-quality biochar now locally available, many view it as a major advancement in turfgrass and landscape soil management. Few, if any, soil amendments offer the same combination of physical, chemical, biological, and environmental benefits. Incorporating high-quality, inoculated biochar into root zone or planting bed soils can lead to long-lasting improvements in soil health and plant performance. Testing results, case studies, recent projects, and area distributors can be found on Standard Biocarbon's website or by contacting the author of this article. Tony Will is Director of New Product Development at Reed Custom Soils. Connect with Tony at reedcustomsoils.com or 617-835-3950. You have been listening to the Turf Zone podcast. Follow the Turf Zone on X, Facebook, and LinkedIn for all things turfgrass, featuring podcasts, magazines, events, and more. Visit www.theturfzone.com for more.